Hi, welcome to AB Video 7.2C Part 1, Extra Volumes by Revolution using disks and wash. Okay, so here's another one, region bounded by this function, y equals 0. Why does this look familiar? Maybe not. Okay, so what? God, I think we did this one. Y equals 2 over x plus 1, which is this graph here. Y equals 0, x-axis, y-axis. So you're revolving about its own border. So you will get a disk. And remember, perpendicular to the axis of rotation, so pi r squared. The radius is this height right here, which is your y coordinate of that point, but everything's in terms of x because the height is horizontal. So you have to replace y by 2 over x plus 1. And of course, left border x equals 0, right border x equals 6. Yeah, I really do think I did this one. All right, cosine 2x. Y equals 0, x equals 0. The x-axis, y-axis. X equals pi over 4, revolved about the x-axis. So the period will be 2 pi over 2, if you remember from Algebra 2. Period's pi, amplitude is still 1. So here is your graph. Okay, it is cosine 2x. Wow, this doesn't, hang on. Hi, sorry, everything's fine. This is the y-axis right here. I was looking at it as if this is the y-axis. So cosine, of course, starts up on top, which is at 1, and then it takes a period of pi in this case. Remember, we figured out the period was pi. So you break that up into 4 parts, pi over 2, pi over 4, 3 pi over 4, maximum, x-intercept, minimum, x-intercept, maximum. So that's the graph. Now it's bordered by the x-axis, the y-axis, and the vertical line x equals pi over 4, which is this line right here. So they're talking about this region. Axis of rotation is horizontal, x-axis, so perpendicular to that would be vertical. And it's going to give you a disk because, again, the border is what you're rotating on. And therefore, we have pi r squared. The height is horizontal, so it's dx. Left border x equals 0, right border x equals pi over 4. The radius, of course, is this height here, which is the height of this point, which is the y, but I have to turn it back into x. Y is equal to cosine 2x. Here's another one. Now this one's a little bit more complicated because it's not one function but two functions. So you have, let's call it y1 is root 2x, y2 is x squared. So this is y equals root 2x, and the red one is y equals x squared. So the region bordered by the red and the black would be this green region right here. You're rotating on the x-axis, which is not a border. There is no flat border to this region. So this will give a washer. Again, you have your little heights, little height, reproduce, and there's your washer. So it's pi big R squared minus little r squared h. Your h this time is dx, so the left border is x equals 0, as you can see. You will have to find the x coordinate of the point of intersection right here. So that's done over here. I set the two equations equal to each other, blah, 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 blah. I find out that they intersect at x equals 0 and at x equals cubed root of 2. So integral from 0 to cubed root of 2. Now, the radii, so slow down here. The big radius goes from here to here, which will go from here to here, which is the y coordinate on the function y1. So it's y1 squared. The little radius goes from the axis of rotation to this point, and the y coordinate on that point comes from y2, which is x squared. So replace by y1 by square root of 2x. Let me just fix that. That does actually go all the way across. Minus, and then your x2 is, your y2, sorry, is x squared, etc., 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 from that point on. Okay, generate the given region about the specified line. So what they have is they have the region, actually let me pause and pull this up from the textbook. Okay, so here's the graph from the book. So we have our curve y equals x squared, which is the parabola, and then you have the line y equals x, which is this green line. Now, it's saying take that region and rotate it about, oh, R1, okay. Let me actually fix this a little. Okay, so I've drawn these little lines to help you. So region 3 is this region down here below the parabola, bounded by that line x equals 1 in the x-axis. Region 2 is the region between the two curves, and region 1 is bordered on the top by y equals 1, on the left by the y-axis, and on the bottom by the line y equals x. Okay, so there's 3 different regions, region 3, region 2, region 1. So for number 42, we're taking region 1, which is this green region right here, okay, above the line, and we're rotating it about the line x equals 1, which is this line over here. Okay, so vertical axis of rotation means horizontal strip within the shaded region. Okay, we're going to rotate it this way, which is not one of the borders, which means we're going to end up with a washer. Okay, so it's pi big R squared minus little r squared h. Your h in this case is vertical, so it's dy, so this has to be y equals to y equals, which is bottom to top. The lowest spot on there is y equals 0, the highest spot is y equals 1. Now we need the big radius, which is the radius from here to here, coming back up. It's this whole length here, which of course is 1. And then the small radius is this little blue guy right here. To get the blue guy, you're going to have to take 1 minus the x-coordinate of that point. But you can't leave the x. You have to rewrite it in terms of y. Now that x-coordinate, that point is sitting on the line y equals x, so you can replace x by y. And then you have the next one. Okay, so for the next one, oh, actually, I didn't do that one. And you know what? I'm going to take it away to make this a faster video for you. Okay, these are all out of the book, so you can certainly try others. And